So last time we saw some variable expansions, and I want to review them again, to revisit them again, just to make a better explanation. For example, if I have an empty variable, so foo is a variable, but it has an empty value, or maybe it is unset, undefined, the variable foo. If I say echo foo, and then here I place some value, then I'm going to get this value instead, because this is unset. So the logic is like this: if 0 foo, then echo is unset. Else echo foo. So it is like testing the value of the variable, whether it is 0 or not. If it is 0, or if it is unset, it is empty, then this value is used instead. Otherwise, it is used the value of the variable. Or another way to write this if command is like this. This is more compact. 0. Actually, it is not. It is not correct. So we are testing whether the value is empty, and if it is empty, then we echo this value is unset. But what happens if it is not empty? I'm not sure if this works correctly. Yes, it works actually. So if this is not empty, then this is executed instead. Another one which is similar to this one. Let's set foo empty again, and it is similar to this, but it is like this with this equal sign. And now, after this is executed, we have also an assignment. So if this foo is empty, then we use this value instead. But we also assign this value to this variable. And with an if condition, we can write it like this: if 0 or if empty foo, then foo gets the value is unset. So this is an assignment. We are assigning a value to this variable. And then we also have echo foo. So we have also an assignment if we use this operator instead. And another one is that we saw is this one. Let's say that foo is empty again. And then instead of minus or equal, we have this plus. Now, this is the opposite of this one. It is the opposite of this one. Value is set. But so if the the variable foo is not empty, then its value is going to be changed to this one. If it is empty, then it will remain empty. So in this case, foo is empty, and this one is also empty. It is left empty. But if foo is some value, non-empty value, then in this case, it is going to be replaced. It is going to be replaced by this value. And the value of foo itself is not changed. So if I write an if that is equivalent to this one, it would be like this. If now this is non-empty, if foo is non-empty, then else echo foo, which is actually empty. Foo is actually empty. So if, this we are checking if foo has some non-empty value. It is non-empty. It is not empty. If it is not empty, then we use this value instead. Otherwise, the value of foo is used, which is actually empty. And in a more compact way, it can be written like this: non-empty foo and echo value is set, or echo foo. Yes, foo is not empty, but if foo is empty, then we just echo this one, which is actually empty. Now we have seen some string operations, and now let's see some more operations with strings. We will see the operations about case conversion from lowercase to uppercase and so on. So let's say that foo has this value. So what is foo? A, B, C, D. Now, if I use this construct, this will convert it the first letter to lowercase. And if I write it like this, it will convert the whole string to lowercase. So it is getting the value of foo. So this is usually getting the value of foo, but with this comma at the end, it converts the first letter to lowercase. If there is a double comma, it converts the whole content of the string to lowercase. And the foo is, of course, unchanged. Now let's give it another value, which is lowercase letters. And if we append this this head, this caret, the first letter of the string is converted to uppercase, and if we double it, the whole string is converted to uppercase. It is also possible to declare a variable such that this variable can contain only lowercase or only uppercase letters. For example, declare foo. I'm declaring a new variable foo, but I'm saying that it can contain only uppercase letters. So if I assign some value to it, for example, this one, it contains both lowercase and uppercase letters. What happens actually is that only uppercase letters are stored into the string. So this string is actually converted to uppercase because I'm declaring this a variable that contains uppercase letters. And it is similar for lowercase letters. Let me declare a new variable foo. So I'm declaring this a new variable. It is overriding the previous declaration. This is a variable that can contain only lowercase letters. For example, I'm assigning this mixed case string, and I'm checking the value that is stored in the variable. It is only lowercase characters. And we have seen this declared previously as well with this R, which is read-only. So if I declare a variable with this R, which means read-only, it is like a constant, which means that after assigning a first value to it, it is not possible to change it again. For example, I'm assigning, okay, it does not allow me to assign a value. I have to assign a value straight away here. Okay, so because I have declared it, so it is most useful in scripts. So once you declare it as read-only, it is not possible to change its value anymore. Okay. Now let's see some arithmetic evaluations and expansions. So we have seen before that this construct can contain an arithmetic expression. An arithmetic expression contains numbers and numeric operators. And let's see some operators that can be used here. First of all, this is a number in the decimal base. So it is a normal number. So its value is converted to decimal to base 10 is the same number. But if I write, for example, 077, if the number starts with a 0, it is an octal number. So it is on base 8. So this 077 is 63 in decimal base, because it is calculated like this: 7 times 8 plus 7 times 1. So this 7 is 7 times 1, and the second 7 is 7 times 8. And that's why its value is 63. And a number that starts with 0, 0 and x is an hexadecimal number. Hexadecimal number is number with base 16. And because it has 16 digits, we also use the letters A, B, C, D, E, and F besides the letters, besides the digits 0, 1 to 9. So the digits that can be used in a hexadecimal number are 0 up to 9, and then A, B, C, D, E, and F. So this number FF in base 16 is equal to 255. And a number that is written like this, it is a number in base 2, which is a binary number. So this means the following number is a number in base 2, binary number. And we can use the same syntax for other bases as well. So if I do it like this, 7, this is a number in base 7. So it is 6 times 7. Yes, it is 6 times 7 plus 6 times 1. And of course, here we can use all the possible arithmetic operators. For example, plus, or minus, or multiplication, or division. This is integer division. It shows only the multiplier, not the remainder. And if we want to get the remainder, we use this one. It is the operation that gets the remainder of dividing 5 by 2. Let's write a simple script that uses some arithmetic operators. Demonstrate the modulo operator. I will write a for loop. I less than or equal to 20. And then I is incremented by 1. Do. And then done, which closes, which is the end of the loop. The variable remainder will get the remainder of dividing I by 5. So I'm dividing I by 5 and getting the remainder. So I divided by 5, the remainder of it is stored into this variable, remainder. Now, I'm checking the remainder. If the remainder is equal to 0, then printf I. So this is the formatted string that will be. So this is print formatted. This is the formatted string that will be printed, and this %d will be replaced by the numeric value of this variable. So this is D for digit, I think. And else printf just %d and the space, and here the value of I is placed instead of this one. And let's close the if, and then here printf. We are printing a new line character as well, so that it goes to the next line. So let me save, and then quit, and then change mode +X, make it executable, and then let's try it. So it is printing. It is a loop that is printing the numbers from 0 to 20. But if the number is divisible by 5, it is marking it. So in some way, the other numbers are just printed normally. We can also modify it a little bit. How? For example, instead of writing this I is assigned I plus 1, we can write plus I, similar to C. It will increment the value of I of the variable y I by 1. So this is similar to C. And also this variable is used only in this place. So we can just do this operation here inside these braces, and then remove this line. So I can just do the division here and the remainder operator, actually. And because this operator takes precedence to the comparison operator, this division is done first, and then the comparison. And let me remove this line. Let's try it again, and the result is the same. So inside this, the arithmetic expression inside this double parentheses, for comparison, we use a double equal sign if we want to compare that something is equal to something else. If we use just a single equal sign, it means assignment. So it is not comparison, it is assignment. And we can check this with a test command. For example, let's say that foo is empty, because let's use another variable. Let's say that bar is empty, and now if bar now what is happening here is that we don't have a comparison here. We are not comparing whether this string, which is empty string, is equal to the number 5. This is an assignment. So we have that the number 5 is stored to the variable bar. So this is actually an assignment, and this assignment is successful. And so that's why the test condition of if is successful, and this is printed. It is true. So this is an assignment operator, not a comparison operator. Besides this assignment operator, we have some other complex or composed operators, assignment operators like this. For example, plus equal. These are similar to the C language, or minus equal, or multiplication equal, or division equal, or remainder equal. And let's see some examples with these operators, and also with the operators plus plus and minus minus, incremental and decremental operators. For example, let's say that foo is assigned the value 1. Okay, let's take this other variable. Let's say that bar is assigned the value 1. And then we say echo and then so when we append this plus plus, we first get the value of the existing value. We use the existing value of the variable, and then it is incremented. So the echo is just printing the existing value of this variable. And then the value is incremented by 1, and when we check its value, then it is 2. But if we do it like this, if we prepend plus plus, the value is incremented first, and then it is used by echo. So the echo is getting the incremented value. Some other operators are binary operators, which operate on the bits of the number one by one. Such operators are, for example, left shift or right shift. Let's see, for example, what does this operator left shift does. For example, let's say that we have the variable x with the number 5. Now, the number 5 in binary is written like 101. So this is 4 and this is 1. Now, if I apply this operator left shift, then this can also be thought like this: 0, 0, 0, 1, 0, 1. Now, if we shift them left, then the first bit is dropped, but another 0 is added to the m. And the value of the number is increased. Now this is 10, I think. So let's say x gets the value 5, and now echo so this is shifting the bits of this number by 1. And when the bits of the number are shifted by 1, we get this number, which is 10. And if we shift them by 2, for example, we shift them twice, then it is like adding another 0 here. And if they shift them 3 times, it is like adding. So this is left shift. If we do a right shift instead, now from the 5 we get the number 2 because this one here is dropped. So the number 5 is 101, and we shift it to the right, and it becomes just 10 because after the shift this digit is dropped, and 10 is equal to 2. And some other binary operators are this one, AND, which is an which performs an AND operation on all the bits in 2 numbers, and this operator is an logical OR, bit by bit OR. So if we have 2 numbers and we use this operator, then it performs an bit by bit OR operation, and this is a XOR operation. So they may be used sometimes if needed. Let's see an example with these shifting operators. For I from 0, I less than 8, incrementing by 1, or plus I do. So we are shifting the number 1 by I places. And when I is equal to 0, it is shifted 0 places, it is 1 itself. When I is 1, it is shifted by 1 place, and it becomes this one, which is 2. When I becomes 2, it is shifted by 2 places and to the left, and it becomes 100. 100 is 4. And if I is 3, when I becomes 3, it is shifted to the left by 3 places, and it becomes 1000, which is 8 in binary A, and so on. So this command actually is printing the powers of 2. And the truth value inside these arithmetic operations is an arithmetic truth value or a logical truth value, but this double parentheses converted to success or failure, so that the if command can use it. For example, if 1, then echo true, else echo false, and close the if. So this one is true. Inside this represents a truth value, true value inside the arithmetic expression operator. Otherwise, 1 in bash scripting is an error. So by default, it represents an error, and 0 represents success. But these are switching the arithmetic value to the bash truth value. And also the same is for numbers. For any number different than 0, it is true. Even a negative number, something different from 0 is always true. And if it is 0, then it is false. So it is the opposite of the truth value of bash scripting. But these parentheses are converting it. There is also a so-called ternary operator. Ternary operator because it has 3 operands. So it is not a binary operator with 2 operands, or it is not an unary operator with 1 operand. It is a ternary operator because it takes 3 operands. And we can explain it with this example. Suppose that the variable a has the value 0. A ternary operator is like this. So it has 3 parts. One part before this question mark, it is like this. So there is one part here before the question mark, one part here, and one part here. This is the test. Something is tested, some condition. If the test is true, then this expression is the value of the whole ternary operator. Otherwise, if this is false, then this expression is the value of the whole ternary operator. So it is similar to an if-else, if then else. So if this condition a less than 1, then this is done. Then plus plus a, else the third thing is done, minus minus a. No, this is not correct. Actually, this is used in the case of an assignment. For example, let's say that we are assigning some value to b. And this is equivalent to this. So if this condition is true, then this value, this is assigned to b. Otherwise, this is the value that is assigned to b, or the result of this expression, because it is actually an arithmetic. It is actually an arithmetic expression. Let's write another script with arithmetic expressions. This is a script to demonstrate arithmetic operators of operations. We have a variable finished, which is initially 0, and then another variable named a, which is initially 0, printf, print formatted, print with a certain format, A, and then this tab, and then A, and then another tab, and then A, and then a new line character. Another printf, and these are tabs again, and this is a new line character. And let's write an until loop until finished do, and then close until with done. B is assigned the value of A. This is the power operator. So this is A square. This is A to power 2, or A square. And C is assigned the value of this is A to the third power. This is like this is the power operator, this double star. And another printf, and we want to print a digit, and then a tab, and then another digit, and then a tab, and then a third digit, and then a new line. And now the first digit is A itself, and the third digit, the second digit is B. It is this one here, and the third digit that is printed is the value of the variable C. And let's use also a ternary operator. A is less than 10, question mark. This is a test condition. Plus plus A, increment A by 1. Otherwise, finished is assigned the value of 1. So we are doing the test condition here before the end of the until loop, and we are checking whether A is less than 10 or not. If A is less than 10, then we increment A by 1. Otherwise, if A is equal to 10, because A is being incremented, A was initially 0, and then it is incremented by 1 here. If A is not less than 10, it is equal to 10, then we assign the value 1 to finished. And when we assign the value 1 to finished, we come here at until loop, and we check the value of finished. 1 means true, and this will stop the until loop. So let's try this script. Change mode plus X. So this is what it is printing. So the first printf is printing this, and the second printf is printing this. And inside the loop, we have another printf that is printing these values. And in the first column, we have the numbers from 0 to 10. In the second column, there are their squares, and in the third column, there are the cubes of these numbers. And if we have to make some complex arithmetic calculations, then we can use the we can use the binary calculator, which is BC. BC is the binary calculator. BC, and then so this is an input redirection. So instead of getting the input from the keyboard, which is the standard input, the default standard input, it is getting the input from the rest of this line. We can also do it like this. With a pipe operation. So we are piping this input to this command. So again, it is getting the input from the pipe, and the input that is coming from the pipe is this arithmetic expression 2 plus 2. Here there is an example script that is using this this calculator. This is a script to calculate monthly loan payments. We save the name of the program.
May I have a question?
Yes, Anton.
You did the two examples, the second one with echo and a pipe, and the first one with the direction signs.
Yes.
My question is, which one is faster of the two?
I believe this one should be faster. I'm not sure. Maybe they are the same, but in this case, maybe they are the same. I don't know.
Okay.
We have to write some test script to test which one of them is faster, but
okay.
Yes,
it's not important. I will do a test afterwards.
Yes.
Okay.
It is possible, for example, to do a complex operation and do it, for example, 1,000 times, repeat it 1,000 times, for example, and measure the time. For example, for I in, let's say, 1,000, do done. It is actually very fast. And then time here. Let's say, or also let's redirect the output to the dev null, so that we see only the script. Oh, this is 100. Let's make it 1,000. So it is taking 2 seconds in general, and let's try the other one with echo. It is taking 3 seconds, so this one seems to be faster. For example, let's try it with 10,000. It should take roughly 20 seconds, so it is taking a long time.
Okay, sorry, I don't want to waste time.
Okay,
But
and maybe this will take 30 seconds. So this seems to be a little bit faster. Yes.
Mm-hmm. Okay.
So let's have a look at this long calculation script. So here we have the program name, and then this is the function usage, which shows how this program is used. And the usage shows us that it is used like this. After the program name, we have to give it 3 arguments. And the first argument is the principal. The second argument is the interest, and the third argument is months. Principal is the amount of the loan. Interest is the percentage of that has to be paid, and months is the length of the loan's term. So this is how this script is used. And we check the number of arguments. This is the number of arguments. If it is different from 3, then we show the usage and exit with an error code, because it requires 3 arguments. Without 3 arguments, it cannot produce a meaningful result. Here we are getting the arguments, the first argument, and we are storing it into the principal variable. The second argument is assigned to the variable named interest, and the third argument is assigned to the variable named months. And then we are doing some calculation with this program BC, and the input is actually taken from this here document. And because of you appending this one to the operator, we can use a tab here. So we can insert tabs in front of the line, and they will be ignored. And this makes it a little bit more readable. So the first command that is passed to the calculator is scale gets the value 10. So this is another variable, a variable inside this calculator, and we assign the value 10 to this variable. And now the variable I gets the value interest divided by 12. So this interest is a shell variable, and it is replaced by the shell. So it is replaced with the value of this variable. Also, this is replaced by the shell with the corresponding value. So it is stored in P, the principal, and the number of months is stored in the variable N. So these variables I, P, and N are internal variables of this program, inside this program, BC. And then we make this calculation with this complex formula that I don't really understand, but this is multiplication, this is addition, this is power, raising something to a power. This is division, and we also use parentheses to use the correct order of operations. And finally, the result is printed. So to test this example, run calc. And the third is 180. This is the number of months. And I think this shows how much per month should be paid. Something like this. And it is giving it with this precision because it is determined by the variable scale. So this scale equal to 10, it is the precision of the calculations. And that's why it is giving this many digits after the decimal point. After this. And for more information about using the command BC, we can see its manual, man BC, or info, which is not installed in this shell, but anyway. Now we will start with another subject, which are arrays in Bash scripting. But before starting, let's download the examples, because these are from lesson 14. So we need to download the examples of lesson 14. wget https Linux examples lesson 14. Let's extract the files in this archive. tar extract. This is verbose. This is for unzip, and this is for the file lesson 14. Okay. So arrays are variables that can hold more than one value at a time. So a variable contains one value at a time. If we assign a second value, it will override the previous value. But arrays can contain several values. For example, I'm assigning the value foo to the first place in this array A. And to get this value, actually, we have to show also the place in the array. So we have to show the place in the array where the value is stored. And because we are using these square brackets, we also have to use this curly braces to delimit the name of the variable. Otherwise, it will be interpreted as something else by the shell. So let's say that we are defining another variable, another array, and we can define it like this with multiple values. So I'm defining this array, and I'm assigning a set of values, some values to this array. And to get a value from the array, first of all, the name of the array surrounded by curly braces, and then also the place of the array. So in this place, we have this value. Let's say 1. In the third place, or in the place with index 2, there is this value. And if we use a star, what we get? If we use a star, then we get all the values in the array. And this is something else. If we omit this these curly braces, we get a different result. Why? Because this is interpreted by shell like this, and this is a string. So there are two strings that are concatenated. It is this string and this string. And by default, if we don't specify the index of the array, then it gets the first value by default. So if we just say the name of the array, but without an index, by default, it gets the first value, which is this one here. And then this string is concatenated to that one. So that's why we get that's why we get this result. And yes, if we use the name of the array without a position in the array, then the value in the first position is displayed. We can define the values of the array also like this. So we define them like this, but we can also specify the places. For example, in the place 0, assign sun. In the place 1, assign none. In the place, or maybe let's say that we want to make it A, B, C, for example, the indices. So by default, the indices are 0, 1, 2, 3, and so on. But let's say that we want to use different indices. So if we want to get the first value, let's say day, and then let's say index A. What happened? I've missed something. So maybe I should just stick to numbers. Yes, there is something wrong here. Okay. So we can specify indexes like this. So in the place with index 0, store this variable. In the place with index 1, store this value, and so on. Let's see this example script that contains some cases of using arrays. So this is a script that counts files, but by modification time. And the usage is simple. The name of the script, this is the name of the script, and a directory as an argument. So it gets the name of a directory as an argument. First, we check that the argument is a directory. So the first argument, $1, we are testing whether it is a directory or not. If it is not a directory, this is the not operator. If it is not a directory, then we display the usage and stop the script with an error exit code. Otherwise, the script will continue normally. We are initializing an array here. So here we assign the value 0 to each item of the array, and there are 24 indices. So I is getting a value from 0 to 23. So there are 24 indices in total. So hours 0 gets the value 0, hours 1 gets the value 0, hours 2 gets the value 0, and so on. So all the items are initially assigned the value 0. And here, this is the part that collects the data. This is the name of the directory. But by typing /* we get a list of all the files in this directory. So this is a shell expansion, and this is replaced by shell. It is replaced with a list of all the files in this directory. And this command stat gives statistics, I think, about each file. So let's try this command. For example, let's say that the directory is the current directory. And I think it is giving statistics for each file in this directory in a certain format. So this statistic is for the first file. So this statistic is for the first file in the array. This statistic is for the second file, and so on. And in the script, we are getting only the hour from all this line. We are getting only the hour, I think. So here in the script, we use this cut, and we count by characters and get the characters 12 and 13. So I guess it is only the hour. And let's check it. So it is actually extracting only the hour from each line of statistics. And so this is a list of hours for each file, and I is getting each value in this list one by one, and this is removing a 0 from the end. So if it is or from the beginning, for example, if it is 0, 1, then it becomes just 1. So this is removing something from the beginning, and it is removing a 0. So if it is 0, 5, it becomes 5. So this j is the hour, and this ++ is increasing the value in the jth position of this array, because this is an array, and initially all the values are 0, but they are incremented when we find a file that is modified or created in this hour. And this count counts the number of all the files. And so this is collecting data. We collected the data in this hours array, and also the number of all the files in the count variable. The count variable, and here is the part that displays the data. These two lines are like header of the data, and then for I in 0, 11, there are 12 values here from 0 to 11. J gets the value 1 plus 12, and then we printf in this format, digit digit. There are four digits separated by tabs, and here we display the index, for example, 0, and then the number of files that are modified at this hour, and then this is I plus 12 here, and the number of files that are modified at this hour. And at the end, we also print the total number of files. So let's test this script. Usage, it requires the directory as an argument. Let's give the current directory. So what does it show? It shows that at 1 o'clock at the night, there are 8 files that are modified at this hour, and all the other hours there are. For example, at 10 o'clock, there are 0 files that are modified. So actually, all the files have this time are modified at the same time. How can we test it? For example, with another directory. For example, okay. So at 12 o'clock at the night, there are 30 files that are modified at this time. At 2 o'clock, for example, there are 16 files. At 3 o'clock at the morning, there are 122 files that are modified, and so on. At 2 o'clock p.m., there are 168 files. So these are the kinds of statistics that this script is producing. And the total number of files is this one, 1,889. So let's stop for today and continue tomorrow with discussions.